Hello everyone. Today I will present a project about a wind turbine. A wind turbine is a complete mechanical system used to convert wind energy into useful power. This project focuses mainly on the mechanical aspect of the wind turbine, such as motion, torque, generation, and power transmission. The mechanical system plays a very important role in the operation of the turbine, as it's responsible for capturing energy and transferring it through the system. In this presentation, I'll explain the general idea of a wind turbine, the mechanical principle behind its operation, the main component, how it works, its benefit, and its engineering importance. General idea of wind turbine. The general idea of wind turbine is to capture the kinetic energy of wind and convert it into useful energy. Wind is moving air, and because it has velocity, it contains kinetic energy. Instead of allowing this energy to be wasted, the wind turbines uses a mechanical system to transform wind motion into rotational motion. This rotational motion is the main mechanical output of the system and is later used to generate electrical energy. Wind turbine operates without fuel and do not produce harmful emissions, which makes them a very important solution for clean and sustainable energy production. Mechanical principle. The mechanical principle of a wind turbine is based on converting linear wind motion into rotational motion. Wind naturally moves in a straight direction, but the turbine blades are designed with a specific shape. When wind flows over the blades, a pressure difference is created between the two sides of the blades. This pressure difference generates a force that produces torque around the rotor axis. Torque is the key mechanical factor that causes the blades and rotator to rotate. As long as wind is present, torque continues to be generated and the turbine keeps rotating. Main component. A wind turbine consists of several mechanical components working together as one system. The blades are responsible for capturing wind energy and starting the motion. The rotor holds the blades and rotates as a single unit. The main shaft transfers rotational motion into the system. The gearbox adjusts the rotational speed and torque to suitable values. The tower supports the entire structure and provides a mechanical stability. Each component has a specific mechanical function, and failure of one component can affect the performance of the whole system. Working principle. The working principle of the wind turbine can be explained step by step. First, wind hits the blades and causes them to rotate. Second, this rotational motion is transferred to the rotor and then to the main shaft. Third, the shaft transfers motion to the gearbox, where the rotational speed is increased. Finally, the mechanical energy is delivered to the generator to produce electrical energy. This process clearly shows how mechanical motion is the main input that enables energy conversion. Now, after explaining the working principle, we can see a short animation that shows how the wind turbine operates in real life. As shown in the video, wind causes the blades to rotate. This rotational is transferred through the shaft and gearbox as mechanical motion. The animation helps visualizing how mechanical components work together to transmit motion and power through the system. Benefits: wind turbines provide clean and renewable energy by using natural resources. They help reduce environmental pollution and dependency on fossil fuels. From an engineering point of view, wind turbines are efficient systems used in power generation, wind farms, and remote areas. They represent a partial mechanical solution for large-scale energy production. Engineering importance: wind turbines are widely used in many engineering applications around the world. One of the main applications is electrical power generation in wind farms, where many turbines work together to produce large amounts of energy. Wind turbines are also used in remote and rural areas where traditional power sources are not easily available. In this location, wind energy provides a reliable and clean source of electricity without the need for fuel transportation. From an engineering point of view, wind turbines are applied in large-scale energy projects because they are efficient mechanical systems capable of operating continuously under different environmental conditions. They are designed to work in open areas, offshore locations, and high-altitude regions where wind speed is higher. In addition, wind turbines are an important application in sustainable and renewable energy systems. They help reduce environmental pollution and support the transmission from fossil fuel to cleaner energy sources. This makes wind turbine a key engineering solution for modern energy challenges. Why this is a mechanical system? This project is considered a mechanical system because its operation mainly depends on mechanical principles. The wind turbines work through motion, force, torque generation, and power transmission, which are core topics in mechanical engineering. The first mechanical aspect of the system is motion. Wind causes the blades to rotate, and this rotational motion is transferred through mechanical components such as the rotor and the shaft. Without mechanical motion, the system cannot operate. Another important mechanical concept is torque. When wind flows over the blades, it creates aerodynamic forces that generate torque around the rotor axis. This torque is responsible for driving the entire system and transferring mechanical power. The system also involves power transmission. The mechanical power generated at the blades is transmitted through the shaft and gearbox to other parts of the system. This shows how mechanical energy is transferred between components in a controlled and efficient way. In addition, structural stability is a key mechanical factor. The tower and supporting structure must withstand wind loads, weight, and vibration. Proper mechanical design is required to ensure safety and long-term operation. For this reason, the wind turbine is clearly a mechanical system based on fundamental mechanical engineering principles. Conclusion: in conclusion, the wind turbine is a clear example of a complete mechanical system used in real-time engineering applications. It shows how mechanical motion and energy conversion can be used to produce useful power. This project demonstrates how wind energy is first converted into mechanical rotational motion through the turbine blades. Then, this mechanical motion is transmitted through different mechanical components such as the rotor, shaft, and gearbox. These processes enable the system to operate efficiently. The wind turbine also highlights the importance of proper mechanical design. Each component must be designed to handle mechanical loads and ensure smooth and safe operation. Overall, this project shows how mechanical engineering principles are applied to solve real-world energy problems. Wind turbines represent an effective mechanical solution for clean and sustainable energy production. That's all. Thank you for listening.